config. But because you are not using Hangouts, I don't know whether the meeting code matters.
No, it shouldn't matter. Okay. So now.
Yeah, I turn off the microphone.
Can you guys see my screen?
See your Finder.
Okay. There you go.
Breaking news.
Oh, and then to record, does it just start recording?
You want me to start recording?
Yeah, well.
Okay, let me dive in.
I can do it. I can just quick record, right?
Yeah, I think so.
Yeah, I think the catch is if you present, you still be able to configure the recording.
Oh, okay.
So
what should I do?
But in that way, if you hit record, it'll just.
yeah, you will record.
Yeah, that's fine.
I'm recording here.
Okay.
1, 2, 3. Oh, request record permission from the meeting host. Okay, thanks for that.
And who? You're the meeting host, I guess?
Yeah, it's recording right now.
Oh, okay.
Sign up. Hi, welcome. Today, Martin will continue his presentation on the config architecture. Are you guys hearing me well? Okay, good. So, so before we start, again, please put in your names and the attendance in the meeting notes. That helps us to see who has been in the meeting. So. And if you have questions, then we can follow up. That's easier.
I can't figure out where all my Chrome tabs are anymore. Oh. Okay, so I guess let's get started. So I have this breaking news here. Just I wanted to touch on the topic we discussed last week on concerning service config. So after the review meeting last week, Spike, Joy, Oz, and I met to get some clarity. Thank you, Spike, for staying with us and seeing this through. So fundamentally, we have and there's been I've started some various threads on the news groups on this stuff, but fundamentally we have a cardinality and problem. Which basically boils down to the fact that a single piece of code, single workload, can be implementing multiple services. So we can tell as traffic is as ingress traffic is arriving, we can tell which service it's arriving to and apply the appropriate policies. But for that single binary that's hosting that service, Istio can't tell anything about the identity of the service that's producing traffic that's leaving that workload. So it boils down to the fact that we really need to treat outgoing traffic differently than incoming traffic for service, and we can separate this. So what I'm proposing here is the introduction of what I'm calling consumer config. It's a chunk of configuration state that's associated with a service account. And any pod that operates using that service account is subject to this config state. So you declare, and the attachment model is this similar to how we do for services. So a service config file exists in the same namespace as a service. So if you have permission to mess with the service, you also have permission to mess with the service config. Similarly, we'd put the service account in the same namespace as the consumer config. So if you have a right to mess with one, you have the right to mess with the other. And it ends up being a reasonably simple policy to apply at runtime, right? So we can easily program the proxies accordingly.
Mark,
so
have you done some analysis to know what resources would go into consumer config?
No, not yet. So basically, it's anything that says how I want to talk to the other guy. So it might be number of retries, consumer side quotas, and a few other things along those lines.
Right, because we're going to have to go through some kind of feature validation with customers to see if there's a hard requirement for that type of stuff versus something that can be handled via other means.
That's fair.
You don't necessarily need the complexity.
Then there's also, I think, there's several cases where you can imagine that the same policy can apply on both sides. The consumer can say something and the producer can say something, and the system combines both. Like quotas is an example of this. There's others.
Yeah, I mean, it might be more kind of access-oriented things like quota and security-related things, as opposed like which identity should I assume when I'm going to go talk to this thing, as opposed to necessarily traffic things like retries or circuit breaker.
Yeah. But anyway, the point here is to call out that there is a difference in stuff leaving a service, leaving a workload versus arriving. And this has downstream effects in how we model the system in terms of the UIs that we want to build and the graphs we want to build. So I started, there's a bunch of discussions underway to see how we can deal with this situation. So I haven't updated the architecture doc. I haven't updated the slide deck. But largely, from end-to-end standpoint, it's a fairly modest change to what we've been thinking about. But any diagram that shows service config going somewhere, well, there's also consumer configs going to the same place effectively. All right, so that's the breaking news. Back to our regular program. All right, so last time we went through kind of the overall architecture, the role of Galley as a transformation engine that takes as input a service config and a consumer configs, and then derives from that a bunch of component configs that are delivered through the components in the mesh. So Galley is responsible for taking a series of service configs and kind of slicing them, combining them, optimizing them, deduping them, and scheduling the rollout to the components. All right. So now let's, so that's kind of what we talked about last week. This week, let's continue down the path on about stage rollout. All right, so what are we talking about in the space of config for stage rollout? So Galley is going to do a number of validations on inputs. We think we can catch the vast majority of bad configs up front. But there's always some bad configs that are going to slip through and hit the runtime system. So to manage rollout, stage rollout is about kind of minimizing the blast radius of a bad config. You roll it out to a small number of customers, and you can roll back if there's a problem. So in the typical way of doing this kind of stuff in Kubernetes is kind of pod by pod. You can phase out an old version and bring up a new version. This has a minimum granularity of a pod, effectively. So for very small deployments, it's actually kind of chunky. You could potentially bring down 50% of your service if you have a two-pod service, for example. So we want to do finer grain splitting, more than a smaller grain than a pod. Okay, so what we want to do is provide the core mechanisms, and the operator is the one that actually drives the end-to-end process. So the operator is going to tell us, hey, I want to go from version A of config to version B of config. They're going to control the loop that that increments us from 0% to 100% of the new config. And they're responsible for detecting problems. They make the assessment, is the config rollout proceeding properly or not, and they get to decide whether to do a rollback. It seems reasonable to think that once we get the core infrastructure working, we'll probably provide some optional opinionated form that takes care of this stuff on behalf of the operator. So something that automatically you tell it how many days or how many hours you want for your rollout to last, and it'll check particular metrics to determine whether it's successful or not. But for now, we just provide the mechanisms, and the operator is driving things. All right. So the general idea of what we want to do is, well, let's see, how did I phrase this here? Okay. So when an operator is pushing a new config into the system, they can specify along with that config some rollout parameters that specify that indicates kind of how we want to select between this config and the one that's currently in the system. So you could, and then as the operator wants to move to the as the operator wants to move from 0% to 100% of traffic on the new config, the operator just pushes a new config that changes those selection parameters. So the general model is that a galley is going to take these inputs. So at this point, it means service configs and consumer configs that are potentially, and as it ingests these things, it's now going to observe the new thing that's being pushed and the thing that's already there. And from that, it'll produce blended configs, blended component configs. So those are component configs that contain some state from the old version of the user's config and some, or contains all of the old version state and the new version state in one place with a component-specific selection logic above them. So what that means is, for example, when delivering the config to Mixer, Mixer would receive a component config that's divided into two parts: the old stuff, the new stuff, and it'll use the existing Mixer selection models, the existing Mixer pattern matching approach. Say, if version 1 use this configuration, if version 2 use this other configuration. So from an implementation standpoint, to support this model, Mixer doesn't need to change at all. Pilot, however, it's a more challenging work to support this kind of blended architecture. I talked to Zach about this before. He thought this was in the realm of possibilities. If it's not, then the fallback plan here is to do the stage rollout to the sidecars. We'd have to actually be at the pod granularity for those.
Yeah, I mean, Martin, given that we already have requirements about basically selecting, either workloads or pieces of a workload into not just config rollouts, but also because we have the runtime upgrade process, right, where we also have to be able to select them into, Istio v1 or Istio v1.1. It seems pragmatic, at least, to probably just rely on that mechanism to begin with, because it's kind of like it's a deployment-oriented canarying mechanism for config, which has an analog to what Mixer already does with its selector mechanism, right?
Yeah. Yes, well, so what I'm hoping is to introduce very minimal changes in the proxy to support this, which is so just like we do the matching rules right now, you could match on versions. So just add an extra match clause for that. And then early on in the Mixer Envoy pipeline, we make a selection to decide, is it V1, V2, and communicate that down the line. So
yeah. So I mean, obviously we have an agent running with the workload that's capable of driving that. And yeah, obviously that can be parameterization to pilot to control its selection.
Correct.
Including the selection of which pilot to talk to, right? Because there's also, we want that control. So yeah, as long as we can find a way to line those two up with a sensible config model, right? This might indicate that we need something that controls the node agent a little bit more dynamically than we do today.
Yeah, I agree. Yeah, so getting that whole pipeline straightened out is probably the most challenging part of this whole thing here at this point.
Because I think we do have some short-term plans to at least do node agent work to support the runtime upgrades, because we might actually need that pre-1.0.
Okay. Well, yeah, so the stage rollout, I would imagine, is going to be sometime for the fall. Is where we can probably start doing beta, maybe alpha or beta at that point. So we have some runway there.
Yeah. By the way, I did talk to a bunch of potential users yesterday, and they mostly seem fine with the idea of scoping to workload to control canarying of config. If right, they it wasn't clear whether anything more fine-grained added a lot of value for them.
Yeah.
Other than percentage of traffic, but that's kind of baked in already.
What is the scoping of config changes that we're trying to roll out? Like, I think we discussed this, and I want to make sure that we're still on this page. That like the service is the natural grouping of how we're gonna sort of say that you're moving from config A to config B. So you can't sort of say I'm going to make changes to two different services and sort of atomically, smoothly roll out both of those things.
Correct. So the scope of a stage rollout is a service, and at that point, I guess also a consumer.
Right.
They're orthogonal, and there's no coordination. We don't provide a coordination across services.
Okay.
I don't know how to do this.
Okay. Cool.
All right. So let's see. No version of config. Okay. So let me clarify what I was saying before. So the idea here is that first, it's worth mentioning that we're building on top of an eventually consistent config store, so the Kubernetes API server. And part of my, to me, one of the top priorities of the architecture here is that I want to prevent emergent outages as a result of config push. So if the operator has a valid config A and a valid config B, the fact that the operator is moving the system from A to B should not trigger any emergent failures that because of us. Right? So we should be able to orchestrate the rollout in such a way that everything keeps running at all times. So that's the objective. I don't know if we can get to 100% of that, but that's kind of the North Star. So as far as config distribution is concerned, that's why we have there's a split model here. First, we generate the blended config and distribute it throughout the mesh. So everybody's got the new config state, but the selector, the selection logic that's driving whether we use config A or config B defaults to continuing using the old version, continues to use version A. So distributing the blended config has no visible, hopefully, no visible effects on components running in the mesh. Once we're satisfied that everybody's got this new config, then it's time to start using the new config. So we separate it and we eliminate the issue with the eventual consistency from that standpoint. And so gradually then traffic can move from A to B. Once everything's on B, then we do another distribution pass to all the components so their config only now contains a state for B. And rinse and repeat over time. All right, so the selection process, no, I don't have a picture. Okay, so the selection process, the idea is when a request begins life, we will, and there's different paths where this can happen, but typically, say on a request incoming to a service, early on in this processing pipeline, the proxy will decide based on some heuristic, perhaps just a random number generator or a user identity or that kind of stuff, will decide whether this request should be processed as version A or version B. and we'll send that data through to Mixer. So Mixer, if the proxy was on version A, the Mixer is also going to be on version A to process that request. And similarly, adapters automatically kind of fall in line. And the idea is that for the entire lifetime of that single request, it will be processed as configured for version A. And the idea there is to eliminate these emergent state where some of the system is in version A, the other part is in version B.
I think it's probably worth iterating that this is per service, like when you say lifetime of the request, just to
Lifetime of the request within the context of a service, so this is not transitive cross-service calls. So it's up to the operator to coordinate if there's dependencies from service to service. That's in the operator's problem. All right, so that's basically all I've got on the stage rollout front. Oh, of course, it's people are always worried about this. It's worth mentioning. There's nothing preventing an operator from going from A to B instantaneously, right? That's a degenerate case. In case of emergency, in case of rollback, you can just make it happen immediately. We're not enforcing any policies on that front. Right? Okay. Next topic was multi-cluster model. So the general approach here is pretty simple. In essence, Galley doesn't care. So we're going to run Galley in every cluster, and we expect that the service config and the consumer configs are just handed to Galley from somewhere. So what this means is if you're running in a single cluster environment, the user is going to do kubectl or istio-ctl, whatever, to push config state, and Galley picks it up from there. If you're on a multi-cluster scenario, from the config standpoint, we expect that there's some outside agent that's going to distribute the configuration across the clusters so that Galley can pick it up.
I think it was mentioned in this model, the Galley in each cluster has independent state.
Yeah, so it's very loosely coupled across. It's not even coupled. They're independent instances of Galleys that don't know about one another, and it's up to the user to ensure that the rest of the system is consistent around it. That's our first stab at this. Over time, perhaps we'll find we need some coordination. But so this means, in particular, as we're doing stage rollout across clusters for a single service, they're going to be in potentially different states of their rollout for a single service. That means as a request is being processed for the consistency model to apply, so that only one version of config applies to a particular request, it means kind of inherently the request needs to be processed within the context of a single cluster.
Right. So, Martijn, one obvious case, right, where we have service specifications that span clusters, but service implementations that do not. Right. We will have a situation where the consumer in one cluster is operating in the context of config A, and the service provider in the context of another cluster is operating in the context of config B.
Correct. So, and that's fine because we're not guaranteeing anything across service boundaries.
Yeah, it's just we're stating that that's a limitation, and by implication, operators should be cognizant of trying to make their stuff durable in the face of that.
Yeah.
And if they're going to do that in a distributed fashion across clusters, they're probably, as best practice, also going to do it within the cluster.
That's fair, yes. Yeah, so the point I was trying to make is that kind of vertically, as the request is traveling through the stack, that processing needs to happen in a single cluster. Otherwise, then we're
So do we also kind of, that limitation implies like the downstream component, they are also kind of cluster contained, like independent state per cluster?
So by downstream, you mean?
Like a pilot.
Well, if they're part in the runtime path.
Yes.
So the components involved in the runtime path needs to be need to be fully coordinated. Since pilot's on the outside, pilot theoretically could be outside the cluster, and I think that's fine. But we don't, because it's not participating in this version selection thing at runtime.
Right. So it's going to be interesting, right? If people tend to use lots of clusters, like let's say I put a bunch of clusters in a single availability zone because I like the administrative properties of that. They're effectively uncoordinated because we drew the boundary at the cluster level for coordination. And we're just going to have to tell operators that's the way things are. They might decide to use one control plane within a single availability zone, right? They can obviously share Istio components, but they might choose not to for other administrative reasons.
Yeah, and I think to me this kind of reaches the boundary of my imagination here. I need to see what's going to happen in the real world. It's conceivable we will need to add some coordination because this is too loosely coupled and errors emerge all the time or something.
Well, yeah, I mean, obviously the grand outer for loop, the God for loop, for want of a better term, is going to have to deal with this stuff in real deployments, which is going to force us to put like some of the primitives. Well, what we should probably be doing is validating some of the primitives earlier before we do coordination things.
Yeah, exactly. that's the reasonable path. All right. So in terms of the kind of multi-cluster, the practical considerations in the short term, there's basically three major patterns that kind of emerge here. One is the manual packaging and distribution. So the operators got the intent level, or what do we call it, composable configs. They run a packaging tool that produces a service config file, and then they manually push it into each cluster. And so they're doing this by hand or using some bash script, and that's all there is. So that's probably reasonable for bootstrapping and small use cases. As more complicated situations, you want to start using some form of automation. So this it's very simple. So you're running a tool. It's responsible for delivering the config to all the services. It's effectively you're replacing to all the clusters rather. So you're replacing a bash script with something a little more robust. The next step is where the packaging step is actually combined with the distribution step. So that would be where the composable config is the direct input to the tool that'll do the composition and the distribution all in one step. So I think that's the kind of the sweet spot for larger deployments. It avoids an extra step, and it can provide a decent experience. So for starters, this is what we're going to build. The manual stuff. So we'll have a manual config packager that understands how to do the transformation, and we expect that somebody else is in the business of distributing this stuff. So there could be an ecosystem of tools and support infrastructure that sits around this, but we're not in that space at the moment. Okay. All right. So I think that covers most of the architectural details that we've got figured out so far. And this is kind of the initial set of implementation tasks that we think we can deliver. We're still tweaking those, so we'll see how it ends up. Okay, so first step is to actually get Galley into pipeline, and this is work that Oz has been doing at the moment. The idea is we take the CRDs that the user is authoring and replicate them into using different API groups. And that's the point here is to inject Galley as a component, so it's actually being exercised and immediately separating what the user authors from what the components consume. And that will enable us in future steps to make some forward progress here. Oops, wrong way. Okay.
So, Martin, one question here. One of the things I brought up in the document is you have this kind of internal CRD, and really what we mean is internal API, right?
So
or do you literally mean a stored resource?
So, okay, I think the way to see it here is this is an implementation step in the sense that the cheapest thing we can do is there is already code in Mixer and Pilot that depends on CRDs as means for ingesting their configuration, right?
Right.
So the idea is to actually make them internal APIs as opposed to public APIs. From there on, we can actually say, okay, these public API or internal APIs, we can implement in them in the most efficient way possible.
Right.
That we think, right? So that is probably going to be like, this is kind of a stepping stone.
Yeah.
But I think, once we land there, we can go to the next step and say, okay, what's the right thing to do here?
Yeah. So at this point, it means very minimal changes in proxy in the Plori. What am I doing? Mixing my things. Very minimal changes between pilot and mixer to support this model, and it kind of gets the pipeline in place and makes what these components are consuming private.
Yeah, so I think one of the things I'm interested in here, what I'd like to be able to do with using Pilot as an example, is have Pilot define an API contract. We can obviously start with that API contract being private, which is tailored towards what Pilot wants to do with the information it receives. But have it be an API.
Yeah. So that's this model. Effectively. So let me get there in a couple slides.
Okay.
All right. So service config would be the next step here. So we start with a config model that's exposed to the user that looks a lot like what we have today, but we've now hidden the implementation and the stuff that's delivered to the components. The next step is to start introducing service config as a first-class thing. So the user can now, instead of authoring using the existing config model, can now start authoring using service configs and consumer configs. And in this approach, we support both. So it's completely upward compatible kind of thing, and we generate the same resources on the back end that the components consume. Of course, this is. I'm sure a lot of this work can be done in parallel, but that's kind of the conceptual step process.
Right. This is still assuming that service. This makes some assumptions about the form of service config, right? Because we don't yet have an agreed upon schema for what service config actually is.
Oh, of course, yeah. This is assuming we actually finalize what service config looks like.
Right. So the distinction between external CRD and service config might be moot, right?
Yeah. So the first step might be make a proto that's called service config.proto, and inside of it is all the existing CRDs as protos, kind of thing, right? And just that's your service config, something like that, and then we iterate from there.
One comment that I had was, probably you addressed it early on. I joined a little late, and this is JJ. So there are at least three parts to it that I see in terms of generalizing config, config definition, and second is distribution, and then third one was the runtime application. Is there a reason to combine all three into like one humongous thing, or is it like definition and runtime? I think definition and runtime would be much more useful than even distribution mechanism. But is there a reason for tackling all three?
Oh, well, I think we need to start somewhere. It's fine for us to define a service config format, but if we don't have a way to get it through the system, it's not that useful. So what we've tried to do is kind of understand the end-to-end pipeline and figure out how's the best way for us to get there from an implementation standpoint. And as I said before, as I'm presenting these click stops, these are kind of high-level places where we can be, but I believe that we'll be doing work in parallel so that as we're implementing Galley, we're starting to work on the service config format. So by the time we're ready to use a service config, we'll hopefully have a definition. It's just I don't think we can serialize the whole thing effectively.
Yeah, and it probably doesn't make sense to be in strict order. Like, I'm not sure this one should come before the one you flashed up earlier, for instance. That one.
Yeah. So there's only so much foresight here.
Right.
We'll see as we progress.
That's the reason I was like, if there is a way to just punt on distribution somehow, and then just take care of definition and runtime?
Well, I think that's effectively what this is trying to do here.
Okay.
In this mode, we produce the existing CRDs, deliver them very similar to the existing CRDs. We deliver them in the same way to the components. In theory, pilot and mixer don't need to change relative to this phase. Now, maybe somebody's working on this at the same time, like Jason over there, and he's making some changes there, but it's a freebie.
Okay, got it.
Right. I mean, in general, the goal of this phase should be to reduce the amount of work pilot and mixer have to do to interpret and deal with config. I think that's probably a fair statement, right?
Well, I'd put this in this category. So
yeah, I mean, the difference between those two is slight. So there are two parallel tracks, right? There's the service config track and the distribution track.
Correct.
And we can obviously decide to focus on distribution without looking at redoing the authoring model, right? And we could probably one of those could go end to end. If I had a crystal ball, I'd say the authoring model will take longer to figure out than actually working on the machinery.
Yeah. I agree.
So I think landing the click step 0 in that sense helps, in the sense that Galley is in there, and then we can now start doing incremental changes into the system, right? That was the main line of thinking with click step 0. Let's separate the problems from each other, right?
Yeah.
Now they are independent problems, and we can make forward progress on either one of them. So we can say, okay, service config is experimental. We can have an experimental implementation of service config in Galley. That can be alpha feature or it can be development feature. But that would be independent of the work that we need to do at the delivery level.
Yeah. Yeah. So in fact, to that end, you can imagine click stop 1 and 2 could be done effectively completely in parallel. Mm-hmm. But given the number of humans involved in this project at this point, we need to take reasonable.
Some serialization is probably pragmatic.
Yes, exactly. Let me kill this here. Okay, so oops. So here we're introducing service config as an optional input. The next step here says, okay, now on the output side, let's start actually producing component configs. So that's when the semantics of stage rollout are effectively encoded. We can probably start doing stage rollout at this point in the scheme of things.
So this versus click stop 0, where you implicitly have that external CRD to internal CRD, like storage right back into the Cube API server.
Yeah.
In theory, you didn't have to do that, right? You could have gone direct to this without doing the write back.
Yes. Yeah, that just means it involves more work on the mixer and pilot in the short term.
And that also implies that you need to Galley write from the get-go. That's the other thing, right? So I think it's yes, we can do this, but it's probably going to be a major surgery and involves a new component, right? Which I'm generally in favor of. But the click step 0 is a bit more conservative approach.
Yeah. So okay. I mean, in all things being equal after 1.0, I think pilot might be amenable to some major surgery.
Yeah.
I don't know about mixer, but I'm certainly interested in pilot having a well-defined downstream API.
Yeah, so I think at this stage, when we define the component config, that's when we introduce an API that's you can directly program. And as Jason and I discussed yesterday, you can have this API and have it consume CRDs as well if that's a desirable outcome for the user, right? So as we discussed last week, I think we discussed this, exposing CRDs at this level makes the configuration model more visible to the customer. So they can potentially, during debugging or visualization, they can see the exact state that the component is under. If it's an API, then it gets a little more opaque. But if we do both, then...
Yeah, I mean, obviously we could leave, pilot and mixer currently with their code reading the external CRDs in place, write Galley, have it write to the upstream APIs, and then do the cutover.
Exactly.
That might actually favor that one.
Yeah, that's my at this point. I think it addresses all the needs. The only downside is extra work. We need to do it in 2 ways.
Yeah, I mean, Okay.
All right. So now, okay. So far we've been focused on the kind of how to get a service config file through the system and get that pipeline working. The next step after that, which again can be done in parallel if we have more resources, is the composition model to the left side of the graph.
Can I ask a quick question? In which click stop does Pilot stop listening to the Cube API and Galley start listening to Cube API for I guess what you call topology?
Oh, yeah, I took that out of the picture. So it's not clear. We need to figure out. My most recent thinking in this is that Galley is always in. So both Galley and Pilot will ingest the topology in some form. It's conceivable Galley would call Pilot to get the topology information or something. But I'd like Galley to be responsible for doing at least high-level sharding. So it needs to understand kind of what's available out there in order to do the sharding properly. I think Pilot also needs the topology information.
But like the end state is for Pilot to not need to get that information directly from Cube API, and it just gets it from Galley?
Yeah, I think so.
Well, or it could go the other way.
No, but I think it is right. Right. In the long term, I'd like the contract to be that Pilot just exposes an API that someone has to fulfill to give it the information that it needs to do its job. I think that's a good layer of isolation to have.
So at that point, Pilot becomes strictly a translation layer.
Yes.
I think if you take Pilot today, there's multiple layers within that. So there's the Kubernetes data store config layers, but it's tightly coupled with the model and config generation. So logically, we want to split that out as a first step. So the externalized from Pilot, so Pilot proper is just the API for the model and config generation plus the service registry stuff. That could be in sitting alongside Pilot as a config sidecar in some sense, as maybe an incremental step. So it's still outwardly facing your Pilot is consuming CRDs, but Pilot proper has this API contract that Lou was suggesting.
Yeah, it gives us some flexibility in the long run with an alternative configuration sources.
Yeah.
And right, specifically like the Cloud Foundry guys, I think would really appreciate if we gave them a contract that they could use with Pilot, where they could push config to it, where they didn't have to depend on our configuration pipeline.
So that piece could be intermediate, and that you might decide to keep that in some form, so that you still like the arguments for using CRDs and having visibility into the into config state without having to do a gRPC request may be attractive. So if you keep that piece, you could move it into Galley proper, so you're not duplicating all these kind of config sidecars that are sitting all over the place.
Right.
Incremental approach towards Galley directly talking to Pilot.
Okay, so I don't have a strong opinion if the Pilot would rather be given this stuff, and I think that's a great point from a reusability standpoint. I think it's fine if Galley can communicate that information.
Yeah, and I'm curious if the same thing applies to Mixer. I suspect it might.
Well, Mixer doesn't know very much about the environment as it is. So.
No, but just in terms of the isolation about how it receives its configuration for.
Oh yeah. No. So I'm totally sold on that model. We expose an API, program these things with an API. If we want to have them keep reading a CRD, that's a separable. Okay, so all right. So where was I? So the left side of the diagram. So the idea is, excuse me. With this approach, the user is now able to edit using composable config. So instead of having these big monolithic service configs, the user has little itty-bitty pieces that get composed together to produce the service configs. The user can continue authoring service config. That's fine too. So if they want their own composition model, their own tooling, that works great. And you can still, the system still in this mode is still ingesting the legacy formats. And the final step here is just remove support for the external CRDs. So now the user is either required to use service config or the composable config. And I think we're done. Yes. So so if we're lucky, we get to this point by the end of the year. Well, we need to. No, that's not true. We get to this point by the end of the year. We get to this point a year after 1.0 ships, so we can deprecate the legacy CRDs. And that's all there is. So my plan is to spend a little while to update the doc to consider consumer config concept, weave that through, make sure there's no hard edges, and that's it. Any questions or comments?
Okay, so I think we should clearly separate the better config or better config resource track from the distribution track, just for like sanity, I think.
You mean defining the formats?
Yeah.
Yeah.
We should also look, because we have short-term needs, to make sure that at the component level, we are able to do the things that we want that operators are able to do the things that we want to be able to automate for them on their own with features within the existing resources that we have, so we can get some validation from them in the short term.
Yeah.
And we already have some of that. Obviously, traffic splitting at the network level gives us a fair amount of that. And if we have a similar feature in Mixer, plus the ability to do contextualization to workload just within the API itself without the coupling, right? So operators are still required to make sure that there's semantic consistency. If they say, I want workload A prime using config X, even though Mixer is going to be on config Y, it should probably still mostly work.
Yeah.
Those are relatively constrained problems to solve. And we'll get a lot of really useful feedback around that stuff over the next 6 months as we see rollouts continue to occur. In a general sense, we should probably, obviously keep improving the distribution pipeline for efficiency, for reusability, et cetera, but give customers a little bit of time to kind of get their toes wet. And then look at how we might, we want some solid user feedback to push, I think, either the better config model stuff. I think we're going to want good user feedback from that post 1.0, and also what controls they want around distribution. I think we're going to want some good feedback around that from 1.0. And I don't want to kind of preempt that with development effort too much, while still laying the groundwork for it. Like, we know there's stuff that has to happen.
Yeah.
And we should put some of that stuff in place. There's some stuff that we're doing just for our own sanity, regardless of what the external user experience is like. I think there's reasonable ongoing work there too.
Yeah.
Spike, I know you've thought a lot about this. Do you have anything to add?
No, not really. I think I've had a chance to kind of bring up the concerns.
That was enough trouble already.
Yeah, exactly. So.
I thank you for sticking with us and getting your point across.
Yeah, no problem.
All right, I guess that's it for now. And let's just start implementing.
Okay, thanks, guys. Yeah, we should obviously talk about ClickStop 1 versus ClickStop 3. I think there's some nitty-gritty stuff in there we should get into the weeds on about what would make sense in terms of short-term execution.
Yeah,
because we have some like other short-term goals around reuse, like just to facilitate testing. I think that might influence that prioritization.
Yeah, and I'd love to be able to build a common library that we could just use between all components. So right now it's just Pilot and Mixer, but there's also a service broker, and the CA probably wants some config as well.
I'm massively invested in having those components have as little code in them as humanly possible.
Exactly. So let's one package that contains all this goo.
So
or one microservice that contains all that goo.
Oh, yeah.
So on this front, regarding the short-term goals, actually we just started a wish list, and I can just quickly presenting here. The doc also exists in the drive. So we're putting together something that's not directly dependent on sorting out the service config format, but there's improvement that we want to have. I would invite everybody, if you have other ideas, to put it in. That's things like we have been thinking about. I haven't put in much about the distribution part of the work that we have talked about, pilot APIs in this doc, because it's well captured in the ongoing architecture. But
actually, I actually don't think that part is well captured in the ongoing architecture. It's been a pretty recent discussion in the context of pilot. So I think we should capture it here. And right, the goal there, what I was thinking about asking, Costin or Sriram or someone like that to do is to, at some time when they have bandwidth, take a stab at defining what they would like the downstream API to look like. I think that will be very valuable.
Yeah, and it needs to be an API that it needs to be an API that makes it so we can support CRDs on top if we want. So something that reports proper status, for example.
Yeah, and probably has some synchronization, state tracking aspects to it, so that when pilot comes back up, it's going to say, I'm at this level of update. Right? Give me all the things since my mark, whatever that is. I think that will facilitate, in particular, situations where pilot might be remote from the configuration source, possibly larger network, which is a concern.
Yeah, and yeah, I failed to mention this in the presentation. I show Galley in every cluster, but in my mind, that's a logical split.
Right. We could, in theory, have Galley in one cluster and Pilot Mixer in every cluster.
Well, I can also have Galley not in any cluster and in a hosted environment somewhere else.
Yeah. I mean, that's the same basic pattern. Right?
Yeah, exactly. So just logically in every cluster, physically.
And that's, Spike, for context, that's somewhat analogous to, the Envoy APIs pattern, right, in ADS.
ADS? Oh, the aggregated?
The aggregated.
Yeah.
So kind of something similar for Pilot to receive its config.
Yeah, I'm just sort of starting to think through, like, what might that look like, and especially if you wanted to make Pilot very lightweight, you would probably want to reuse a lot of those XDS concepts.
Oh yeah. Yeah, it's the same basic problem with just a different form. The other thing we probably want Pilot to be able to do is to do read-through for EDS to another system. Or just have other systems be able to implement EDS, basically.
Yeah.
That's the one segregation, right? Endpoints are almost totally orthogonal to all the other aspects of them. Okay. Yeah, that was really helpful, Martin. I think we're on a good track here. We just have some interesting details to work out. But
yeah, I'm actually pretty excited. I think this is going to be very good for the platform and customers.
Yes.
Well, thank you very much. See you guys later.
All right. Thanks, guys.
Bye.